Hello everybody, my name is Natalie Colbert. I'm delighted to join you today and discuss our Torrens Early Learning Centre, which is a certified passive house premium that was a commercial building built in 2018, and we finished our certification and received that this year, 2020. Bit about me first. I am not a passive house designer or certifier. I'm an owner operator of the Torrens Early Learning Centre, and I'm a childcare professional. I own and operate childcare buildings here in Canberra. This was the 4th childcare centre I was building, and we decided that we would build this building to reach the commercial passive house standard. What did we build? Well, Torrens Early Learning Centre is a childcare centre here in Canberra, Australia. Childcare for us is nursery, which is babies, through to preschool, so from 6 weeks old to 6 years old. And we educate and care at this facility up to 90 children per day, and we have 26 staff on the premises. What did we build? We built 2 new buildings. We built a brand new 2-storey classroom building, which has 6 classrooms and 3 bathrooms, and it's over 480 metres squared. We also knocked down and rebuilt 1 new 2-storey admin and nursery building that's 289 metres squared. And in that building we have 3 bathrooms, a commercial kitchen, 3 kitchenettes and a dining room. So why did we build it, and what did we have as our goal? Our goal was to build a sustainable and comfortable energy efficient building, and the success measure for us was that we had a sustainable building that would be healthy for the children and that would be built to a high quality standard that would have enduring quality. So for my presentation today, I'll just talk a little bit about the building in terms of the passive house components, and I will also go into some of the challenges, failures, and the successes of what we did. First of all, on the energy supply, so we are connected to the grid, but we also have a 30 kilowatt Fronius Eco solar system installed on the north facing of the new building. We also use 2 Sandon Eco Plus hot water heat pumps. We do not have any metered gas or use any natural gas at all. Energy. So what do we use and what does it cost? This is probably one of the things that we talk about the most, which is how efficient energy-wise our building is. So as I said before, I operate 3 childcare centres here in Canberra, so we could do a very good cost comparison. So at Torrens Childcare, we generate 25 kilowatts more energy than we use, and we pay about $3 a month in electricity. At Urambi Childcare Centre, which is a 4-year-old building that was very well built, has high levels of insulation, double glazed windows, but does use gas heating and cooling, we pay on average $2,392 a month for our electricity and gas. For my other centre, Majura Park Childcare, which is a 11-year-old building built to the Green Star rating, so it's certified Green Star rated building, we pay on average $2,100 a month in electricity and gas. And those prices have actually increased in 2020. So at Torrens, I won't go through all the details, but what do we use and what does it cost? You can see here that we generate more energy than we use, which is one of the key components of being a premium passive house. I should note that the rate of rebate is very low. So you'll see that our consumption in October 2019 was 1,290 kilowatt, but our electricity generator was 2,333. So the rate of rebate is low. We also have to pay a supply charge to the government because we are connected to the grid. After that, this rebate we worked out is equivalent to only paying $3 a month. So when you compare that each of my other centres I spend on electricity and gas per year, roughly $30,000, And at Torrens, we spend roughly $36 a year for electricity. That's very efficient when you look at the cost of the 30 kilowatt commercial solar system that, after the government rebates here in Australia, only cost us about $24,000. So we made our money back in our first year by installing the solar system and by having such a high energy efficiency building. So everyone wants to know how we built it, and this is the details. So obviously the first component was the air tightness. We used prefabricated insulated panels that were made in Melbourne by the company Carbon Light, Panel Light, and they were supported by Intello Plus internal airtight membranes. We used Solitex Extanza and Mento external membranes for the other two buildings, and we used Tescon Extora tapes on the joints and Seeger on the windows. Our concrete slabs were sealed, carefully engineered, and then there was on-site management of all the thermal bridges. So you can see some of the photos of the building whilst we were going underway. Our insulation, obviously we had an insulation diagram and requirement to meet. Our external walls were insulated with 144 millimeters of fiberglass batts. Our internal walls, we had additional insulation to meet fire regulations and sound and noise requirements, and we used earth wool for that. We had insulated roofing that was 240 millimeters of fiberglass batts, and we insulated the floors, which were on concrete slabs, and we used Kingspan Cool Therm XPS, so 50 millimeter. On the new building, we had CLT that came from Germany, provided by Panel Light, was used as the flooring. So our ERV systems, we have 4 System Air VTCs, Save 700 ERV systems. Just to give you a bit of a detail of how that has worked, I can assure you the building is extremely comfortable. We've been working and operating the building for just over 2 years now. It does maintain a constant temperature that is only fluctuated when we open and close the doors so much, but the temperature sits between 20 to 22 degrees. We did install small independent mechanical HVAC systems into each classroom, and we do need these because this is an educational building. The doors are frequently opened and closed, and unfortunately they do not open into a closed corridor. They open onto an open walkway straight out into the breeze and the heat. So what didn't work? The building design didn't work perfectly for Passive House because of the layout of the classrooms, access to the corridors, so that does affect the way our ERV systems work. And some rooms struggle. The small rooms do not have their own ducting. There is one small office and 2 small cot rooms, so sometimes they are hot or cold. Our educators and families don't appreciate the way the ERV system works or the way that air tightness is a requirement in Passive House. They don't listen at all about keeping the windows and the doors closed, and they will not. So I will frequently find doors left open for fresh air in all weather, hot and cold. At the same time I will do that, I will see that the mechanical HV will be running at max power. The Passive House details for the windows, we used triple glazed, thermally broken, low emissivity imported windows, and they came from Neufner in Germany. We also used external window shading, so we have roller shutters that go, we have both aluminium, some with daylight strips and some with cloth that work on the different facades. What worked really well, we did manage to get 0 thresholds fitted for our exits, which need to be approved for disability access. What didn't work? We had some issues with fire and emergency access and egress because we need to be able to, as an educational facility, we need to be able to exit the building at all times even and not be able to lock the doors internally. So we had an issue with the lock catches and we had to do an expensive retrofit to put new turn catches on the inside. So what did it cost? This is probably what everyone's really interested in if you're coming from a building background. First of all, I'll just say this was a construction management build. So it was me as the owner operator building the building in conjunction with a builder who worked to me. That does have an effect because we weren't outsourcing to a commercial contractor. This is a premium build. I'll also explain. It has 5 bathrooms, 6 kitchenettes, a commercial kitchen, dining room. We used tiled and glass balustrated surfaces. So it's a very expensive fit out for a high quality education facility like this. And you can look at it as well. It has over 21 toilets. So our total build cost was actually $2,613,000, and this is without GST, or $3.14 million with the GST. GST is the goods and services tax of 10% in Australia. Now this also included about $58,000 for our playground, and there was, as I said before, a lot of money went into top quality tiled and glass balustrated balconies, etc., to meet childcare regulations. This cost wasn't separated between the old and the new buildings, and our total indoor square meterage was 768 metres. So essentially we worked out that the total build cost worked out, you can see the calculation below, at around $3,347 per metre squared. This is considered low for a Canberra commercial build. Usually commercial builds start at around 4,000 square metres, and particularly noting the number of bathrooms. As I said before, it was an owner construction management contract, not a commercial contract. So that did keep the costs of management down. However, it did also have in there over $160,000 for consultants in our architecture, which was also special disability and landscape architecture to be a childcare facility. There was also $16,000 for valuations and $5,000 for contamination reports. So overall, this was a low build cost. It did not, and I'll be very clear on that, it did not cost significantly more to build passive house than having built from a commercial contract for a lower quality building. So some of the challenges, I think the first challenge we often talk about is team building. It took over 18 months plus of planning, and that was hydraulics, mechanicals, architectural, and ways to meet the building code, issues such as the kitchen exhaust. There was engineering meetings of how we were going to achieve the passive house standard and how we were going to match and meld that into the Australian regulatory requirements of both the building code here and the childcare requirements. We also had to find capable tradespeople who could handle a commercial double-storey build to the passive house standard. I've put a picture in there of, at the top right, that is our oven, and that was one of the examples of how complicated it was to meet the commercial VCA requirements. We needed to manage our kitchen exhaust, and what we had to do was come up with a solution that would work for both passive house as well as the BCA requirements, and that meant we ended up with a $35,000 commercial oven with its own self-reticulating exhaust hood. So that fits into my ventilation issue. We spoke about airflow a lot and filters a lot. On many occasions we had some fantastic mechanical engineers, 4 mechanical engineers were involved in the build, talking about ventilation for pretty much 18 months prior to the build and during the build. Finances, we also had issues with finances here in Australia. We had approved finance to start the build to the right amount, and the bankers had agreed, and then they reneged on paying upfront payments for the prefabricated system. Essentially, a risk management system came into it, and they said they wouldn't pay for systems until they were installed on site. This was very difficult with the prefabricated panels coming from Melbourne, and they would also not pay for the windows and blinds until after they arrived on site from Germany. Everyone will understand that the German manufacturers will not make or ship windows or blinds to Australia until they've been paid fully upfront. So that meant as a builder, we needed to achieve an additional $1 million of upfront cash. That delayed the project for 4 months. Some other building challenges, we had fire safety issues. Australia was not used to building with CLT or some of the systems we were doing. We were also located next to a natural playground, so we had to meet special fire requirements. So that was quite expensive and complex to meet. It required extra insulation, extra shielding of the windows, extra locations for exhausts, and extra systems for fire check prevention inside the building. We had continual issues with air tightness. We had very contracted responsibilities to all our subcontractors on how we would have to, and they would have to manage air tightness. We explained Passive House and our requirements over and over again. We kept penetration diagrams, but we would still find that tradies were damaging the membranes and not admitting it, and we found that our contracts were not enforceable. So on one occasion we came back and I found over 23 penetrations put in by data cabling, even though they had known very clearly what our responsibility and their responsibility was. We also had a very disastrous break-in over Christmas on the build, so the day before Christmas when we'd closed the site for 3 days, and they came in and damaged the windows. This was a very lengthy and expensive and difficult to repair a broken window in Australia to get the right type of glass and recertified to the right level. We had some issues with the blinds. The blinds that came from Neufen in Germany had the wrong frequency loaded into the motor, so it was a frequency we were not allowed to use in Australia. And we also had some poor installation, which was our own inexperienced trades on how to install these new products. We did fail. I'll be quite blunt, the smaller building, the rebuilt nursery admin building, did not meet the final airtight criteria, which was a very expensive outcome. We had done airtightness tests before the build and done extremely well. And then after, with the final trades, we did not do as well. We particularly noted our security and fire trades and cabling had come through and made over 35 punctures behind and through walls. This was after the internal plastering was complete, and you can see I've put in a picture of one that I just found just before the final airtight test. I just looked and saw a yellow cable hidden up behind a wall, and there was it just punctured through. We had all of the provisions to do, and we had trades on site who could fix these holes and penetrations at every time, but explaining continually to tradesmen their responsibility was always an issue. There's another photo just below of one of the ducting gaps, and you can't really see it, but essentially the trades just cut straight through the membranes, and they thought that just by sealing it around a bit of the wood and sealing it a bit around the duct that would meet the Passive House requirement. So that took hours in a very tight, cramped spot to try and redevelop an airtight layer around ducting. Our success. I think we can be justifiably proud at how successful this building is. It was the first commercial passive house built in the Southern Hemisphere, and certainly we were very, very proud to receive the premium rating. It is very cost efficient. It is remarkably efficient to operate the building. It is an absolute delight to work in Torrens Early Learning. It is comfortable for all of the occupants. It is truly quiet inside, which is one of the blessings of having triple glazed windows, but you can also notice the fresh, clean air. The solid temperature without having to put on HVAC, so you're not hot or cold, is really enjoyable in an office building, and it's great for our young babies as well because they're not being exposed to blown heat or blown cooling on top of them. It's healthy. We're delighted to say that we've tested the humidity frequently, and we know that it's very good and it sits at the right level to help reduce airborne virus transmission. That's particularly relevant right now. We also know that with our filtering systems of the ERV that we have a low level of allergens internally. This is very good for our children with asthma or anyone who's suffering from hay fever. One of the best outcomes and really noticeable things we could measure about how successful the building was in January 2020. So Australia was on fire And during these Australian bushfires, Canberra was rated as having the worst air quality in the world. I put up a little World AQI rating showing us on January the 2nd. If you see the picture down below, you can see that there's our Australian Parliament House shielded by orange smoke. So during that time, I actually moved my family into the building. There's my daughter there. We set up mattresses inside and we stayed there for over a week because the air was unbreathable outside. I think that's a good success measure. So would I do it again? This is a question that people frequently ask me. As an owner builder and an owner operator, would I do it again? The answer is resoundingly yes. I would certainly take any opportunity I could to build another passive house building. I would build, if I could, I would retrofit my other centres to this standard. I think that I would see that the cost efficiency and the quality of the building would make such an expensive retrofit and difficult planning and programming worth it. I'm absolutely looking forward to building a residential passive house for myself whenever I could get the opportunity to do so. I'm a proud supporter of passive house builds, and I'm always telling everybody and showing everybody the joys of our building. We certainly have set a new standard here for an educational childcare facility in Australia, and I know that many of the regulators are impressed about the accomplishments. I would just like to take, if I could, this very short opportunity to thank everybody who supported us during the passive house build. As I said before, we would have 18 months of planning with up to 11 engineers in the room, and the support from Laros, the support from Panelite Burkhart, our designer Harley from H3, and our certifier Luke from Detail Green are really inspiring, and they were the ones who kept us going during the entire build, particularly when sometimes things were hard.